you have a DFA D if D accept some string, okay, at least one string, some string of length n minus 1, of length n minus 1, then what you can say, then can you guarantee, then can we guarantee that language will be infinite? What do you think? Can you guarantee? If DFA D accept some string of length n minus 1 where n is the number of states, then in this situation can you guarantee that L will be infinite? And the answer is yes. The answer is yes, you can guarantee that language will be actually infinite. Let me prove it to you. The proof is actually very easy. There is a DFA D, okay, and this has total n states. So for a moment, let's assume that you have 4 states. Okay, I am assuming that you have total 4 states. And this DFA accepts, let's assume this DFA accepts, just assume that this DFA accepts W equal to some string W equal to ABA. You can see length is n minus 1. Is this clear? Basically, the number of states is n, and this is accepting this string A1, A2 and so on, AN minus 1. Okay, this string is accepted. Is this clear? So let's assume that this is accepting this string. Now you tell me, can you guarantee that the language will be infinite? The language will be infinite? Yes, you can guarantee. See, notice one thing. Okay, let's try to make sure that there is no loop. Try to make sure that there is no loop in DFA from initial state to any final state. Okay, because remember, the language will be infinite. Please understand this. Okay, this property, please understand that if you have a DFA, then when the language will be infinite, if you have a DFA, let's assume you have a DFA D, then remember LD will be infinite. LD will be infinite if and only if there is some loop. There is at least one loop in the DFA from initial state to some final state. If there is at least one loop in DFA from initial state to some final state, from initial state to some final state. Okay, is this clear? So remember, the language actually will be infinite. For DFA, the language will be infinite. When can you say the language will be infinite? When this type of situation happens, that from the initial state, this is your initial state, from the initial state to some final state, okay, to some final state. This is one of the final states. Okay, this is some final state. This can be any final state. Okay, so remember, this is some final state. Now, the language will be infinite. When the language will be infinite, the language will be infinite if and only if there is some loop from initial state to some final state. On the way, there is some loop. Okay, there is some loop here. Means on the way there is some loop. Is this clear? Okay, on the way there is some loop. So this is what I'm saying, that the language of DFA will be infinite if and only if there is some loop in the DFA. Okay, in the DFA on the path from initial state to some final state. I can say on the path from initial state to some final state. I hope you understood. Is this clear? Let me know. Is this point clear? This is a very simple point. If you have a DFA, then the language will be infinite if and only if there is some loop on the path from initial state to some final state. Means if this type of situation is there, from initial state to some final state on the path, if there is some type of loop, there is some kind of loop, okay, then in this situation the language will be infinite. Now what I am going to do, now you try your best. Okay, try to make sure there is no loop from initial state to any final state. Okay, let's make sure that You don't bring any loop. Is this clear? Please tell me what I'm doing. Did you understand? See, the DFA has 4 states and DFA is accepting a string of length n-1. The number of states, this is basically n, and the length of this, you can see the length of w is basically n-1, that is 3. Okay, now what I will do, I will try to make sure that there is no loop in the DFA on the path from initial state to any final state. Okay, so if I want to do this, then what I will have to do? Tell me. I want to do this. So this is your string. Your string is basically A, B, A. This is your string. You will start in the initial state. Now remember, this string is accepted. Please understand, this string is accepted. Because this string is accepted, so this is final state or not? This last state is final or not? Yes, this is final. Yes or no? Because this string is accepted. We are assuming this string is accepted. Okay, this W is accepted by DFA. This is accepted by DFA. So because this is accepted by DFA, so this state, this last state will be final state. Okay. Now make sure there is no loop. Make sure there is no loop. Tell me, if I do this Q0, okay, means on this A, if I'm going from Q0 to Q0, then there is a loop, yes or no? If I do this, please understand, if I do this, there will be a loop. If I do this, there is a loop. Okay, I got a loop. Loop found. Okay, loop found implies infinite language. Yes or no? Is this understood? Please tell me. So you can see, if I do this, means from state Q0, from the initial state on symbol A, if I go to initial state, then there will be a loop. It's like this. Basically, you got this type of loop you got from Q0. This type of loop you got. Yes or no? You got this type of loop on the way to Q final. So I hope you got it. So you got a loop, so the language will be infinite. So this cannot be Q0. Do you agree with me? Do you agree with me that this cannot be Q0? Because I don't want any loop. I don't want any loop. Okay, no problem. Let me take Q1 because I have 4 states. I have 4 states. Yes or no? I already have 4 states. Is this clear? Okay, accepted by DFA. In this DFA, there are total 4 states. You have total 4 states. So I can use Q1. There is no problem. I can use Q1. Okay. Now you tell me one thing. If I use this Q0 here or this Q1 here, either Q0 or Q1, then will I get a loop if I use Q0 or Q1? Here, if I use Q0 or I use Q1, then will I get a loop if I do this? If I do this, yes, again I will get a loop. Yes or no? Again I will get a loop. So if you do this, again loop found. Again loop found. Okay, loop found means again infinite language. But I want to make sure that I don't get infinite language. I want to make sure I don't get infinite language. So I cannot do this also. Let me use some Q2 and let me use this Q3. This Q3 is the final state. Let's assume. Okay, Q3 is the final state. So now, can I say I have avoided all the loops? Okay, see, very interesting thing is coming. Please understand. Very interesting thing is coming. Can I say I have avoided all the loops? Can I say I have avoided all the loops? So can I guarantee that there is no loop? Can I say there is no loop? Can I say there is no loop on the path from initial state to some final state? On the path from initial state Q0 to some final state, that is your Q3. Can I say? Please tell me. This is an interesting question. So can I say there is no loop? Can I say there is no loop? Can I say there is no loop? See, there will be a loop. There will be a loop because it is a DFA. It is a deterministic finite automata. See, there will be a loop. Notice. It's something like this. From this is the initial state. On A, you are going to Q1. On B, you are going to Q2. On A, you are going to Q final. Okay, Q3. Now, okay, now notice this is a DFA. So in the DFA, in the deterministic finite automata, From every state, on every symbol, you must make a transition. Yes or no? From every state, on every symbol, you must make a transition. Agree with me? Do you agree with me? This is a DFA. Because this is a DFA, so from every state, on every input symbol, you must make a transition. Is this clear? Because this is a DFA, deterministic finite automata. So from every state, on every input symbol, you must make a transition. Tell me where you will make a transition from Q3. Just make a, this is what I'm telling you. Make transition from Q3. Now make transition from Q3. First of all, you tell me, is this necessary? Is this mandatory that Q3 must have transition on A, B? Is this mandatory? Tell me. In the DFA, in the deterministic finite automata, is this mandatory? Is this necessary that this final state Q3 must have some transition on A, B? Yes, that is the definition of DFA. So now you make transition from Q3 on A, B. Where you will make? Where you will make? If you make a transition. Now where you will make? Wherever you make, you will get a loop. Okay, whatever you make. For example, if you make transition like this, you got a loop. I got a loop. If I make transition like this, I got a loop. Whatever you do, you will get a loop. Are you getting my point? This is the interesting proof. I hope you understood. See, whatever you do, you will get a loop. Notice, you got a loop. Is this clear? I hope you understood. See, you got a loop. Whatever you do, you will get a loop. Okay, you can do whatever you want, you will get a loop. Is this clear? If you do like this, you got a loop. Is this clear? Please tell me. So, that is the final thing. So, you can see our final conclusion is that if DFA has n states and you are accepting some string of length n-1, then language must be infinite. Is this clear? Is this clear? Please tell me. DFA has n states, and if you accept some string of length n-1, then the language will be infinite. LD must be infinite. Must be infinite. And I hope you understood. I hope you understood the proof. Did you understand the proof? Please tell me. Because if you want to avoid the loop from initial state to any final state, if you want to avoid the loop, then remember at the end from the final state where you will make a transition. See, this is the simple point. I hope you got it. What I am trying to tell you. Very simple point that from the initial state, this is your string. Your string W is A1, A2, A3 and so on an-1. Okay, you are accepting this string. So at the end you are in the final state. Okay, you are accepting this string is accepted. So at the end you are in the final state. Initially you are in the initial state. Now, if you want to avoid the loop from the initial state to any final state, from the initial state to this final state, if you want to avoid the loop, then what you need to do? You need to use all the new states. Okay, keep using new states. Keep using new states, you keep using. Okay, but if you keep using these new states if you keep using, then this will be what? Okay, so for example, let me start with, yeah, so this is Q0, so this will be n-1. So you can see there are total n states. So you have consumed all the n states. Is this clear? You have started from Q0 to Qn-1. So you have consumed all the n states you have consumed. Now you can notice, after doing this, where you will make a transition from QF, yes or no? Where you will make a transition from QF means from here where you will go on A. Just notice, from here where you will go on A and where you will go on B. Is this clear? Where you will make transition on A, where you will make transition on B, because if you make transition to any state, you will get a loop. Is this clear? If you make transition to any state, you will definitely get a loop. Very simple. So from Q0, okay, you can go to Q final, that is fine. Okay, Qn-1, this is your final state. But now if you make a transition on A to this state, let's assume you are making a transition on A to this state, then you got a loop. Then we got a loop. See, this loop we got. Yes or no? We got this loop. Is this clear? Please tell me. So we got this loop. This is the loop. Okay. So the language must be infinite. So that's it. Is this clear? So in this type of situation, the language LD must be infinite. Okay. So is this point clear? Please tell me, is the proof clear? Is the proof clear? So let me give you this statement. Okay, I am giving you this statement. This is a very nice, beautiful statement I am giving you. And that is, if you have a DFA, DFA D with n states, there are n states. Okay. DFA D with n state, there are n states. So DFA D accepts infinite language. Accepts infinite language if and only if. This is a if and only if statement. Okay, DFA D accepts infinite language if and only if D accepts some string of length greater than equal to n. If and only if D accepts some string of length greater than equal to n minus 1. Okay. Now remember, the same statement I can also say greater than equal to n length. That is also fine. The same proof will work. Yes or no? Is this clear? The same proof will work. Notice one thing, what I am telling you. See, if DFA accepts, if DFA D, there is a DFA D with n states, there are n states. Okay. Now I am saying that if DFA D accepts some string of length n minus 1, then also language will be infinite. Accepts some string of length n minus 1 or more. Okay, is this clear? So you can see, if DFA D accepts some string of length n minus 1 or more, then language will be infinite. Will be infinite. Yes or no? So this statement is, we have already proven. This proof we have already seen. Already proven. This proof we have seen. We have seen proof. Okay. Now the same statement, remember, of course, if the DFA accepts a string of length n, then also the same proof will work. Yes or no? Same proof will work. I can say the same proof will work. I hope you understood. So remember, if the DFA is accepting some string of length n or more, then also the language will be infinite. And if the DFA accepts some string of length n minus 1 or more, then also the language will be infinite. Okay, is this clear? NFA with n states. There is a NFA with n states, and this NFA is accepting. This NFA accepts some string of length n minus 1. Some string of length n minus 1. Of length n minus 1. Then what you can say? Then can you guarantee LD will be infinite? Then can you guarantee LD will be infinite? Then LD infinite, can you guarantee? Please tell me, can you guarantee LD will be infinite? Let me know. Can you guarantee LD will be infinite? The answer is no. You can easily give a counter example. For example, okay, let me give you counter example. You can take n equal to 2. So 2 states you have. Now consider this NFA. Just consider this NFA. Okay, you can consider this NFA. Is this clear? Just consider this NFA. Now you can notice the language is also finite. The language actually is a comma b. This is the language. But you are accepting a string of length n minus 1. Is this clear? Please tell me. Okay. So now did you understand that NFA does not need transition from the final, this last state? Yes or no? Now are you getting the point? Can you connect the dots? Please tell me. Can you see what happened in the case of DFA and what is happening in the case of NFA? See, in the case of NFA, it is not mandatory that this state has transition on every symbol. It is not mandatory that this state has transition on symbols. Is this clear? So you can have missing transitions. In the NFA, you can have missing transitions, dead transitions you can have. So you can see, this is the idea. But in the case of DFA, from this state you must have a transition to some other state, or maybe from this state you must have a transition to itself. Yes or no? So in the case of DFA, every state must have transition on every input symbol. But in case of NFA, you can have dead transitions. Okay, is this clear?